Question number 10 from Miscellaneous Exercise chapter 4 asks us that this equation 2px square plus 4 times p plus q times x plus 2 times p plus r equal to 0 has equal roots. We know that this discriminant should be equal to 0 in that case. They are asking to express p in terms of q and r. Now make sure you understand that they are not asking about the value of p, the value of q, the value of r. That is three unknowns and you cannot find the value of three different unknowns from one single equation. Okay, so we don't have enough more information that can give us the values of p, q and r. We just can rearrange the answer in such a way that we have p on the left side and q and r on the right hand side. That will be the final answer. So do not stress yourselves out on this. So we need to find the coefficients a, b and c from the quadratic equation. We took a to be 2p, b to be 4 times p plus q and c to be 2 times p plus r. We take the condition b square minus 4ac equal to 0. We plug in all the values. If I square this, the square of 4 will be 16 and the p plus q will get a completed square on it. Minus 4 times 2 is 8 times 2 is 16. P times p plus r equal to 0. We expand that further. We keep 16 as same. The square of p plus q is p square plus 2pq plus q square. We multiply this 16p with p plus r. We have 16p square and 16pr, both negative because the 16 was negative. This has 16 in it, this has 16 in it, this has also 16 in it. So all the terms can be divided with 16. So we divide 16 on both sides. We get rid of the 16. So we have p square plus 2pq plus q square minus p square minus pr equal to 0. Both p squares cancel each other. So we have 2pq minus pr. We take the p terms and keep them together. And we take the q square term on the other side of the equation. So now I can factor out p out of this. I'll be left with 2q minus r multiplied with p, and on the other side we have negative q squared. If I want to find p in terms of q and r, I will divide this side on both sides. This part 2q minus r will be divided on both sides. So now I have p equals to minus q squared divided by 2q minus r. We had to express p in terms of q and r. That's what we did. In question number 11 of Miscellaneous Exercise 4, we are just doing the b part because it's a bit different. It's not asking about the value of p, that find the value of unknown for this condition, but it's asking that if you take the equation x square minus 2 times 2p minus 1 times x plus p square plus 1 minus p equal to 0, it's saying that it will not have any real roots no matter what value of p you put in the equation. So if our equation does not have any real roots, that means the discriminant is negative. So the question claims that no matter what value of p you put in the discriminant, it will always be negative. That means no matter what value of p you put in the equation will not have real roots. So the simple process will be that when I calculate the value of d, it will be independent of p. So if I calculate the value of d, the discriminant, every part that has p in it will cancel out and there will be no traces of p in the answer, and answer will be purely negative because negative discriminant leads to no real solutions. So we are finding the value of d. D is b square minus 4ac. Our leading coefficient a is 1, b is minus 2p minus 1 and c is p square minus p plus 1. We put these values in the discriminant, so we put a square over b minus 4 times 1 times p square minus p plus 1. When we expand it, the square of a negative number will be positive, so 2p minus 1 whole square. If I expand it, it will be 4p square minus 4p plus 1. I multiply negative 4 with all these parts, so it becomes negative 4p square. Negative times negative is positive 4p and negative times positive 1 is negative 4. Now this positive 4p square and this negative 4p square cancel out each other. This negative 4p and positive 4p cut each other. So I'm left with 1 minus 4, that is negative 3. Now my discriminant is a negative value minus 3 irrespective of the value of p, so it does not depend on the value of p anymore. That means no matter what value you put in place of p, you will always have a negative discriminant, and that means the equation will have no real roots. We are doing question number 17 part B. This is a bit new, I thought I should do it. It says find the value of c if 3x square minus 9x plus c is entirely above 2.25. So there's no harm in any equation being above any number, but if you look at the type of the equation, it has 3x square, that means the value of leading coefficient is positive, so it should give us a concave upward graph. If it's a concave upward graph, it should have a minimum point, and if that minimum point is even bigger than 2.25, that means the entire curve stays above 2.25 at y-axis. That means it will never come down and will have no real solutions for all values of x. So if you can never have any real solutions, that means your discriminant is less than 0. So this question needs to be solved at this condition. Otherwise there's no way you can find the value of c, because what value of x you will put in order to find the range of c? If there was no c in the question and only it was 3x square minus 9x bigger than 2.25, then we would directly have solved the inequality without putting any values for or any conditions on the discriminant. We did not need any conditions of discriminant in that case, right? So we put the values of b and a and c in the inequality and simplify it. We get the value of c to be negative 9 in this case. We are doing question number 19 from miscellaneous 4. It's a bit trick question, it has a star to it. It says kx square plus 8x is bigger than 6 minus k for all values of x. No matter what you put in place of x, you will have this inequality. Find the value of k. Now usually we have a given coefficient of x square like 1 or 2 or negative 1 or negative 2, a fixed coefficient of x square, so that helps us decide whether it will be a concave upward graph or a concave downward. But in this case they have given us a unknown coefficient of x square. That means we don't know, so we'll assume from our own selves that either the k is positive or it is negative. If I take k to be negative, I can again divide the negative on both sides and turn it into positive. So for convenience we are assuming k to be positive. Either way we will get to the same conclusion. So if I assume k to be positive, look at the inequality. I have kx square plus 8x plus k minus 6 bigger than 0. So if k is positive, I have a concave upward graph that should have a minimum value, right? The inequality suggests that although it has a minimum value, it is still entirely above 0 for all values of x. That means the entire graph is above x-axis no matter what value of x you put. So there's no x value that can bring the graph down so that it can intersect the x-axis. It will never have real solutions. That means discriminant should be less than 0. So we take the coefficients a, b and c, we put them in discriminant less than 0, we solve it all the way down. I get reduced to two factors, k plus 2 times k minus 8 bigger than 0. So my lower root would be alpha minus 2 and upper root would be beta plus 8. We know that in a greater than 0 case, we take x values or k values, in this case lower than alpha or bigger than beta. If I take values lower than alpha, I will need to take k values lower than minus 2. Those will be negative values, but our assumption was k to be positive, so I need to choose k bigger than 8 so that it's strictly positive values. That's what they asked us for.